This video is about the development of physics from its early beginnings to the groundbreaking discoveries of modern times. I'll explain how physics grew from the first observations by the Mesopotamians through the works of Archimedes and Newton to the latest discoveries in particle physics and cosmology. Over 4,000 years ago, Mesopotamians observed the stars. They used simple mathematics to track the movement of planets. Their calendars helped with agriculture. These observations were the first physical studies. Physics was not yet a science. In the 6th century BC, physics began in Greece. Philosophers like Thales asked what the world is made of. Aristotle described motion and natural laws. His ideas were often wrong, but influential. They shaped physics for centuries. In the 3rd century BC, Archimedes in Syracuse studied forces. He discovered the law of the liver and buoyant force in water. His work was practical and mathematical. Archimedes is considered the father of mechanics. His ideas helped later physicists. In the Middle Ages, physics stagnated in Europe. Scholars like Thomas Aquinas studied Aristotle. In the Islamic world, scientists translated Greek texts. They improved astronomy and optics. These works influenced later science. In 1543, Nicholas Copernicus published his theory. He said the Earth orbits the Sun. This contradicted the Church, which saw Earth as the center. His work started the scientific revolution. It changed physics forever. In the 17th century, Galileo revolutionized physics. He used telescopes to discover Jupiter's moons. His motion experiments disproved Aristotle. Galileo introduced mathematics into physics. He is considered the father of modern physics. In 1687, Isaac Newton published his Principia Mathematica. He formulated the 3 laws of motion and the law of gravity. His theories explained planetary motion and daily phenomena. Newton unified mechanics and astronomy. His work still shapes physics. In the 18th century, physicists like Benjamin Franklin studied electricity. They discovered that lightning is an electric discharge. Magnetic forces were also explored. These studies marked the beginning of electrodynamics. Physics became more diverse. In the 19th century, thermodynamics developed. Scientists like Sadi Carnot studied heat and energy. They found laws explaining machines like steam engines. Energy conversion was understood. Thermodynamics was important for industry. In the 1860s, James Clerk Maxwell unified electricity and magnetism. His equations described electromagnetic waves like light. They showed that light is a wave. Maxwell's work was a milestone. It led to modern technology. In the late 19th century, J.J. Thomson discovered the electron. He showed that atoms have smaller parts. This led to new atomic models. The idea that atoms are indivisible was wrong. Physics became smaller and more complex. In 1905, Albert Einstein published the special theory of relativity. He showed that time and space are relative. In 1915 came the general theory about gravity. His formula E=mc² became famous. Einstein fundamentally changed physics. In the 1920s, physicists like Max Planck developed quantum mechanics. It describes the behavior of atoms and particles. Planck's idea of energy quanta was new. The theory was strange but successful. It explains the atomic world. In 1927, Werner Heisenberg formulated the uncertainty principle. It says that you can't precisely measure a particle's position and speed. This idea changed our understanding of physics. Quantum mechanics became philosophical. Heisenberg shaped modern physics. In 1932, James Chadwick discovered the neutron in the atomic nucleus. It explained how atoms stick together. With protons and electrons, the atomic model was complete. This discovery helped nuclear physics. It led to new technologies. In 1938, Otto Hahn and Lise Meitner discovered nuclear fission. They split uranium atoms and released energy. This led to the development of atomic bombs. Nuclear energy was later used for power plants. Physics had major impacts. In World War II, physics was crucial. The Manhattan Project built the first atomic bomb. Scientists like Enrico Fermi worked on it. Radar and code-breaking used physics. The war showed the power of physics. After 1945, particle physics grew. Physicists discovered new particles like quarks with accelerators. The Standard Model explained how particles interact. This research is very complex. It shows the building blocks of the universe. In 2012, physicists at CERN found the Higgs boson. It explains why particles have mass. The discovery confirmed the Standard Model. Accelerators like the LHC were crucial. It was a triumph for physics. In 1916, Einstein's theory predicted black holes. In 1971, they were first observed. In 2019, the first photo of a black hole was taken. They are extremely dense objects in space. Physics helps us understand them. In 2015, physicists discovered gravitational waves with LIGO. Einstein had predicted them in 1916. They occur when black holes collide. The detection was a breakthrough. It opened a new window into the universe. In the 1980s, string theory emerged. It says particles are tiny, vibrating strings. The theory tries to unite gravity and quantum mechanics. It's mathematically complex, but it's still unproven. Physicists discovered that dark matter affects the universe. It's invisible, but has gravity. About 27% of the universe is made of it. Its nature is unclear. Physicists are searching for answers. In 1998, physicists found that the universe is expanding faster. They called the cause dark energy. It makes up about 68% of the universe. Its nature is a mystery. Dark energy drives research. Physics drives technologies like computers and lasers. Semiconductors, developed from quantum physics, are in every device. GPS uses relativity for accurate positioning. Physics changes our daily life. It enables innovation. Astrophysics studies stars, galaxies, and the universe. Telescopes like Hubble provide breathtaking images. Physicists search for life on other planets. The research is exciting. It expands our worldview. Physicists are working on nuclear fusion, the sun's energy source. It could provide clean, infinite energy. Experiments like ITER are promising. It's technically very difficult. Fusion is a goal for the future. Physics is taught in schools to explain the world. Experiments like pendulums or magnets fascinate students. Teachers show how laws work. Physics inspires young scientists. It is a key science. Women like Marie Curie and Lise Meitner shaped physics, but they were long underrepresented. Today, programs support women in science. Their contributions are vital. Physics is becoming more diverse. Physics seeks answers to big questions. What is dark energy? Is there a theory of everything? New technologies like quantum computers might help. Physics drives progress. It remains an exciting science.